Welcome to the marathon, and make no mistake, your Cambridge physics exam is exactly that, a grueling high-stakes marathon. Whether you're sitting for syllabus 0625, 0651, 0652, 5054, or 9702, the core challenge remains exactly the same. It's all about pacing yourself and managing your cognitive energy for the long exam haul. Today, we are cracking open the examiner's playbook to decode the exact strategies you need to master incredibly complex topics, like conductors, insulators, and electric fields. Now, to really understand this, I want you to imagine two different students walking into the exam hall. First, we have Alex. Alex is basically a walking physics encyclopedia. Alex overloads every single answer with massive paragraphs of raw physics facts, but completely lacks any real analysis. Then, on the other side of the room, we have Sam. Sam is the rusher. Sam races through the paper, trying to beat the clock, and completely misses the specific requirements of the command words. Both Alex and Sam are going to lose massive amounts of marks, despite actually knowing the physics. If you've ever walked out of an exam hall feeling super confident, only to get your results back and wonder where all those marks went, you are probably making the exact same mistakes as Alex or Sam. Today, we're putting a stop to that. We are taking a look behind the curtain to see exactly what the examiners are looking for and how you can deliver it every single time.
Listen to this crucial warning straight from the principal examiner reports. This is our hook today, and it proves that how you structure your answer, your visual thinking process, is just as important as the final number you circle at the bottom of the page. Examiners are practically begging students to show their work so they can award points. Think about Sam, our rusher. Sam calculates the force on a point charge, punches the numbers into a calculator, writes down a final answer, and moves on. But what if Sam missed a decimal point? Boom, 0 marks. Now think about Alex. Alex writes half a page on the history of electric fields, but doesn't actually set up the mathematical equation. Again, 0 method marks. Showing your work isn't just about doing the math. It's about providing a clear, logical map of your brain for the examiner to follow. Even if your final destination is wrong, they will give you credit for taking the right path.
To get you those top grades, we are breaking this session down into 6 clear stages. 1. The assessment challenge. 2. Core theoretical principles. 3. The standardized sequence. 4. Our deconstruct, solve, and evaluate framework. 5. Top examiner warnings. And 6. Securing those vital method marks.
Section 1. The assessment challenge. Moving beyond surface-level physics.
There is a very clear dividing line drawn between average students and top performers. The Cambridge Assessment Framework heavily prioritizes analytical depth over superficial breadth. This is where Alex fails. Memorizing isolated facts, like just stating that copper is a good conductor, is superficial breadth. It's not enough anymore. Top-performing students show a connected, conceptual understanding. They decode the command words. If a question says explain, it demands a totally different structure than a question that says state or describe. This is where we need to introduce the ultimate weapon, the Peel framework: point, evidence, explanation, link. Top students structure their physics answers using Peel. They make a point about the electric field, they provide evidence from the diagram, they explain the physics principles at play, and then they link it back to the specific question asked. I want you to imagine a 30-second timer ticking down in your head right now. If you were looking at a 4-mark question about why a charged balloon sticks to a wall, could you quickly spot the difference between an answer that just fact dumps and one that uses the Peel framework? The fact dump gets maybe 1 mark. The Peel answer gets all 4. Section 2. Core theoretical principles, conductors, insulators, and electric fields. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's ground our strategy in the actual physics theory you need to master. Whether you are analyzing an experiment to distinguish between conductors and insulators, or you are examining the electric field patterns around a charged conducting sphere, this electron model explanation must be your absolute anchor. Let's apply our Peel framework here. You cannot just say a material allows current to flow. That's what Sam would do in a rush. Instead, your point is that metals are conductors. Your evidence or explanation involves discussing the mobile, delocalized electrons that enable this conduction, contrasting that specific atomic level behavior with the tightly bound electrons in insulators. Your link ties it directly back to why this specific material in the exam diagram behaves the way it does. This precise, structured terminology is exactly what elevates your answer to a professional examiner-pleasing standard. Remember, the theoretical architecture here rests on precise definitions and causal relationships. Integrating these concepts with other syllabus areas will significantly boost your score. This is where we initiate the transformation. We're taking Alex and Sam's flawed approaches and upgrading them with what we call the physics success blueprint. If you can explain how the forces in an electric field between parallel plates affect the kinematics of a charged particle moving through it, you are proving to the examiner that you know the whole book, not just one chapter. Imagine Alex writing a chaotic paragraph about electric field lines without mentioning the force on the electron. Now imagine rewriting that live, using the blueprint. We cross out the fluff. We add the formula for electric field strength. We relate the field strength to the acceleration of the particle using Newton's second law. Boom! We just turned a 2-mark answer into a 5-mark answer. We took the red pen marks and transformed them into green check marks. You have about 60 seconds in a real exam to plan this kind of rewrite in your head before your pen hits the paper. Cross-topic connections are your best friend.
Section 3. Standardized Procedural Sequence. The examiner's expected workflow.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's get into an interactive workshop. The crucial point here is how we take theoretical principles and process them under pressure. Examiners look for this exact standardized sequence, especially for complex scenarios, like calculating electric field patterns. First, identify key elements. Next, apply relevant principles. Then, execute your analysis with clear working. Verify results and present in the appropriate format. Let's test this. Challenge 1, data scan. Imagine a complex data table showing the potential difference and distance between 2 parallel plates alongside the resulting force on a test charge. You have a 60-second timer running. Can you extract the core trend? As distance increases, what happens to the force? If you followed step 1 and identified the key elements, you'd immediately see the inverse relationship. Sam would rush this and misread the axes. Don't be like Sam. Follow the sequence. Section 4. Deconstruct, solve, evaluate. The master problem-solving framework. Time for challenge 2, find the flaw. When facing a complex electric fields dataset, you must use this deconstruct, solve, evaluate sequence. It hits the descriptive, analytical, and evaluative levels required by the Cambridge syllabus. Imagine a sample paragraph that says, the electric field strength increases because the plates are closer together, so the electron moves faster. Where is the flaw? I want you to identify the sentence losing marks. Have you spotted it? The flaw is that it jumps straight from cause to an incomplete effect without systematic solving. It doesn't mention that a stronger field means a greater force, which leads to greater acceleration. It skips the logical steps. Deconstruct the problem. Break the physics down into bite-sized steps. Solve it systematically on the page. Check if your answer makes sense in the real world and make justified recommendations. It turns a chaotic, rushed thought process into a neat, highly gradable submission that an examiner can easily give full marks to. Moving from basic analysis to evaluative analysis is what unlocks the highest grade boundaries. Now we hit challenge 3, speed writing. You have 30 seconds to write one perfect PL paragraph evaluating an experiment meant to distinguish between conductors and insulators. Go. You need to identify limitations. Maybe the humidity in the room affected the static charge. You need to spot assumptions. This is also where the time management matrix comes in. You cannot spend 10 minutes on a 2-mark evaluative question. You must allocate your cognitive energy based on the marks available. Basic analysis gets you the core marks. Evaluative analysis gets you the distinction. But you have to manage your time to ensure you actually get to the evaluative parts of the paper without rushing like Sam. Section 5. Top examiner warnings. Avoiding the most common pitfalls. We are now entering the final phase, the final system. But even with the best framework, you need to know where students typically trip up. These 3 warnings come directly from principal examiner reports. Number 1, confusing cause and effect. For instance, fundamentally misunderstanding the direction of force on a positive test charge versus an electron in an electric field. Number 2, forgetting to check format and presentation. Leaving off standard form or forgetting that electric field strength is measured in volts per meter or newtons per coulomb. And number 3, providing answers that are not specific to the context. This is Alex's biggest trap. Writing a beautifully accurate essay about insulators that has absolutely nothing to do with the specific diagram of the coaxial cable provided in the exam. Always tailor your knowledge to the specific scenario the examiner has drawn for you. Your physics knowledge is a tool. Apply it exactly where it's needed, nowhere else. Section 6. Securing method marks. Making your thinking visible.
let's lock in the complete physics answering system, the 3 rules that guarantee top marks. Rule 1, command word decoding. Rule 2, Peel framework application. Rule 3, time management matrix. Method marks are your ultimate safety net. They're awarded for demonstrating the correct logical process and clear working, even if your final answer is totally wrong. By explicitly showing your systematic breakdown of a charged sphere problem using those 3 rules, you guarantee method marks. You are telling the examiner, look, I know the physics, I decoded the command word, I used the Peel framework, I just slipped up on the final calculator punch. Making your thinking visible on the paper is non-negotiable.
That is the exact number of marks you will receive if you provide an incorrect final answer and fail to show your working. 0. Don't let your hard-earned physics knowledge go to waste. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acexams_IGCSC, to excel in your Cambridge examinations. Subscribe right now to @acexams_IGCSE and click that bell. Don't let another exam pass you by.
This brings us to the ultimate question for your revision. When you sit down for your next past paper, are you brave enough to make every single step of your logic visible? Master the visible method, pace yourself for the marathon, and you master the exam. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.